Before jump into the key set pagination, we must know what problem it does solves. So let's talk about the traditional approach first, which is an offset based pagination. So it follows a simple skip take approach where we skip some records and take some records. We will skip limit into page -1. It means if our page is 1, then we will skip 0 records. If our page is 2, then we will skip 10 records. If our page is 3, we will skip 20 records and so on, and we will take the limit records. So by default we will take 10 records. So let's hit this endpoint where limit is 10 and page is 1. So it has taken 5.97 seconds. So let's execute it again and it take 68 milliseconds, then 29 milliseconds, 45 milliseconds, and it is taking approximately 25 to 30 milliseconds. When we hit an endpoint again, so it uses a cached query plan, so it is taking less time. So let's just say it is taking 30 milliseconds. Okay, so let's go to the page 2. It is taking a little bit more time. Let's go to the page 100 and you can see it is taking a little bit more time sometimes. Yeah, let's go to the page thousands. So its time is increasing whenever we are changing the page size. Let's go to the extreme and take page equals to 100,000. Now you have been noticing that it is taking too much time than earlier. Earlier it was taking 30 to 50 milliseconds. Now it is taking 602 milliseconds. So the time it is taking to execute is increasing with the page number. So let's check what SQL it generates. It uses a offset fetch base query. So it is just like skip this much rows, fetch next rows. Why it is taking time when we are increasing the page number? For page 1, it skips 0 records and takes 10 rows. For page 2, it skips 10 rows and takes next 10 rows. For skipping, it has to read 10 rows. It is not directly jumping to the 11th rows. First, it has to process the previous 10 rows, then it will jump to the 11th row. When we move to the page 3, it has to skip 20 rows. It means it has to process 20 rows before moving to the 21st row. It is the first problem we face with offset based pagination. It introduces one more problem. The problem arises when someone updates records concurrently. Let's say we are taking 10 rows at a time. Page 1 have records 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and page 2 have records 11, 12, 13 to 20. Let's say you are on page 1 and someone has deleted the 10th record while you are moving to the page 2. At this time, the 11th record will shift to the page 1. So page 1 have records 1, 2, 3, 4, 5, 6, 7, 8, 9 and 11. Page 2 have records 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. When you moved from page 1 to page 2, you are expecting the first record in the page 1 will be 11, but you will see there is a first record in the page 2 is 12. So you have completely missed the 11 record. So let's go to the key set pagination. It is similar like before. We order by book.id, then we will take records which are greater than the last id and we will take the record equals to limit. In this approach we must be aware of the last id, so you need to take care of last id. Let's execute this one. Let's say by default last id is 0, so it will take 1 to 10. Then last id is here 10. It will take records from 11 to 20. then our last ID will become 20. And if we want to access last 10 records, as you have noticed that we are getting equal amount of time every time, is around 20 to 30 milliseconds. Either they are initial records or they are the last record. One problem with this approach is that you cannot directly jump to some page. So if you are on page 1 and you want to directly jump into the page 10, you cannot do that. You have to go through the next approach. So if your application does not have a functionality to jump over a certain page, then consider using keyset pagination. Even if you think that your application need page jumping functionality, then reconsider about it. Do you really need it? That's it for now. See you next time.